Good evening and welcome to the At Right Angles webinar. This webinar was originally scheduled for September, but we had to postpone it because of unforeseen circumstances. We have with us a very familiar face to At Right Angles. Jonaki Ghosh is the editor of the Tech Space section, and many of every issue, I think, has featured a Tech Space article which has been curated by Jonaki. So, welcome, Jonaki. It's a pleasure to have you here.
Thank
I've
you,
noticed.
Sneha. Yeah.
I've noticed that all your articles are based on explorations. So let's start with a very basic question: why explorations? Why are they so important?
Right. Uh, so, Sneha, before we answer that question, maybe we need to revisit very quickly uh, the goals of mathematics education. And the position paper on the teaching of mathematics had articulated it very aptly that it is the mathematization of the child's thought processes. Now, the word mathematization, there is a very nice definition by Hans Freudenthal, who says that mathematics is a human activity. So, the student should, for herself, reinvent mathematics. And during this process, the learner is engaged in an activity where experience is described, organized, and interpreted by mathematical means. So he emphasized the idea of reinventing mathematics by the student. So, do we get opportunities to make that happen in the class? And the position paper had also talked about, making a shift from content to processes and the processes of, use of patterns, estimation, approximation, visualization, reasoning, and proof, problem solving. All these are very critical to learning mathematics. So if we have to make the inquiry based approach, learning by discovery, all these things are to be made possible in the classroom. And the teacher has to pose challenging learning experience which activate the students' mathematical thinking. Then we can do this through explorations. Explorations could be simple, short tasks, or they could also be projects which span over a longer period of time, but where the student gets the opportunity to present their work, present their thinking process, take support from the teacher, and essentially take ownership of their own learning. So I think to make all this happen, it is important to have explorations.
Thank you. Thank you so much. Um, so now the natural next question would be: why is technology so suited for exploration?
Yes, that's a very important and pertinent question. Uh, well, you see, learning mathematics is also means it requires acquiring a certain kind of freedom, the freedom to question, to explore, to experiment, to visualize. And for all these modes of learning, technology in the form of digital tools, if it is used appropriately, it can be a great enabler. In fact, technology should only be a vehicle for exploration, uh, and it should not be used to just for paper pencil tasks. It should be used to do something which you can't do easily using paper and pencil. And if you go through the mathematics education literature, it talks about role of technology. There are two metaphors which are very frequently used, and that the role of technology as an amplifier in the sense that it amplifies the possibilities, it provides opportunities to investigate similar situations at high speed and accuracy. For example, using a graph plotter, you can quickly generate a sequence of graphs or a
Hmm.
table of values. So student can focus on making observations, developing insight through that, rather than getting bogged down by doing the calculations themselves all the time.
Hmm.
So
Hmm.
one is amplifier and the other is reorganizer. Technology helps to restructure our thinking. It gives us access to higher level concepts. And these tend to come naturally in the process of exploration. So I hope in the course of this webinar, I'll be able to show that technology can lead to support for looking for patterns, identifying invariances, making and testing conjectures and so on. So
Yeah.
I feel that is the reason. Uh,
Thank Thank you for making that so clear. And when somebody simplifies the literature on the subject, it just helps so much. And I'm looking forward to, as you say, using examples to illustrate further. So, can
right.
you tell us a little bit about the explorations which you have featured in TechSpace so far, before we come to the one we're focusing on now?
Right. So some of the many of the explorations that have featured in text space in at right angles, it started with the birthday paradox. I think the very first issue, July 2011 issue,
Hmm.
was talked about the birthday paradox, and then later many of the problems rather, were based on probability. So,
Hmm.
for example, the Monty Hall problem, where you have three doors and so on. So, there were many of them. There were also other kinds of, like the Hill cipher method, which focused on how you can manipulate matrices to, code and encode secret messages. But before coming to that, I would just like to add a little bit about the use of spreadsheets, because uh, when we talk of digital technology for mathematics, there's a lot out there, and the very popular ones are dynamic software like GeoGebra, or for higher levels, computer algebra systems like Mathematica and others. But spreadsheets are generally tend to get overlooked. They're underutilized,
Hmm.
but they're very easily accessible, and they are very suitable and conducive for designing inquiry-based tasks.
Hmm.
Uh, and they do not need an extensive knowledge of coding. In fact, because of having lower technical overheads as compared to programming languages, where you need to know a lot of coding, spreadsheets have simple functions which students can easily use, and create a simple simulation and make observations. So I just wanted to make that point before moving on to the kind of things that we will talk about in this
But
webinar.
you used a very crucial word there, simulation.
Yes,
Can you tell
yes,
us a little bit more about simulation?
right. So, in a way, simulation is a method of generating data using random numbers. Now, the
Oh.
idea of randomness is
Hmm.
something we need to understand. And basically, our lives are full of events which have an element of unpredictability or uncertainty. Like if you toss a coin, you can't be sure whether it will turn up heads or tails.
Hmm.
If
Hmm.
you go out for a meeting, you can't be sure that you will be on time. And if you're making investments, you don't know exactly how much you're going to gain.
Hmm.
So, simulation helps us mimic the random behavior of phenomena through the use of programming or through the use of computers.
Okay.
Uh, and you can also use other non-technology based things, but since we are talking about spreadsheets and use of technology, so most mathematical softwares have inbuilt random number generators. Like in Excel, you have this rand command, which I'll just show. And so simulation is about modeling the probability of different outcomes of an event or an experiment.
Okay.
uh,
Okay.
so I'll have to share my screen, just if you give me a moment,
Yeah.
to show you the how we can get it on a spreadsheet. So I'll just quickly share my spreadsheet. So I hope it will be showing on the screen.
Yeah. So you will be showing how Excel simulates different outcomes.
Yes.
Yeah.
So quickly, just is the spreadsheet visible?
Yes. Yes. Yes.
Okay. So under the column B, where it's
Hmm.
written random numbers, now I mentioned that there is a command called RAND.
Yeah.
Uh, so if you just put equal to RAND with brackets, it will
Hmm.
output a random number between 0 and 1. If I press enter, so it just gives me a random number between 0 and 1. Now simply by dragging this cell, I can generate. Now if you see, there's a sequence of random numbers. Every time you tap on the screen, you will get a new sequence. Now there is no way of predicting how what next number will come up. So it's truly random in that sense. And so this command basically helps to generate random numbers between 0 and 1. So this is useful in certain cases. The other is the rand between command. So if you want to generate an integer between a given set of integers, I can use rand between. So suppose I want to simulate the roll of a single die. Now we want numbers from 1 to 6, because when you roll a die, you can get numbers from 1 to 6.
Whole
So I just
numbers.
whole numbers, yes. So I just type 1 comma 6, rand between 1 comma 6, which will, and if I press enter, so here it gives 5, and
Okay.
if I just
Okay.
drag,
So it's
so I get,
literally like throwing a die,
it's die, yeah. So you
simulating
can
the throw of the die. Hmm.
absolutely. So, you can get children to, or actually, you should get children to roll a single die maybe a couple of times, maybe 10 times, 20 times, 100 times, 50 times. But beyond that, it would get a little cumbersome. So, if we have a simulator like this, we can just drag this, and even if you want 1,000 rolls, and if within a second you can get it, and if you want to make observations from that, you can do so. So,
Okay.
so
So
think,
literally, you're widening the scope of the exploration
yes, and
and enabling students to draw generalizations from their
mm,
observations. Okay.
yes, yes. Now, I think I'll move on to the birthday paradox, which you had just mentioned.
Yeah.
This I'll, is the slide visible?
Yes. Yes.
Okay. So the birthday paradox is something interesting. It basically asks a single question that how many people do you need in a group to ensure that there are at least two people having the same birthday? So they could be of any age, but they should have the same birthday, right? So that is the question. Now, typically when you ask this question, the first reaction of many people is it should be 366 or maybe 367 if you include 29th leap year, that is 29th of February.
Yeah.
Now, if you have 367 people with 366 different days of the year as birthdays, and the 367th person will naturally have a match with one of the earlier ones. So there's a 100% probability. But it is called a paradox because in much smaller group sizes, let's say between 60 and 70, even within 60, the probability of a match is very close to 1, that is 100%. So therefore, within in small groups of 60 people, wherever you go, if you just gather 60 people randomly from somewhere, you are certain to find a match. Now, this is people don't believe this. So, the one way to get it done is actually ask people to write birthdays of people they know. So, if you don't have
Yeah.
60 people sitting around you and asking them for their birthdays, you can just maybe if they're just 10 people and each one contributes about 5 or 6 birthdays, so that you have say slips of paper with birthdays written on it. So, if you randomly pick them up, you will find that that set of 60 birthdays has a match. Now, again, we can't keep doing it by using, slips of paper and so on. So, one way is to simulate it again on Excel by randomly generating birthdays. Now, how do we do that? So, like this is just a snapshot. I will show you the actual simulation. So, you need a number for the month. So, month will be 1 to 12, and date will be 1 to 31 because there are months with 31 days. And once you generate a month and a date in two separate columns, now these are the birthdays. Like the first is 22nd of December, and the next is, let's say, 6th of September, and so on. Now, how do you scroll down? And if there are 60 such birthdays, you have to keep checking where is the match. So, one quick way to do that is to convert these pairs of numbers into a single number of 3 or 4 digits, right?
Okay.
And then when you sort this list of
Okay. So the sorted list is on the side. Okay.
yes. So
Yeah.
this is side, and you can see that there is a match. So
Oh,
there may be more, but so let's quickly do this and maybe let me see what it. Can you see the?
yes.
So very quickly now we you are familiar now with the rand between command.
Huh.
So I want between 1 and say 12 for
Hmm.
the month, and I drag the same command here and modify it, and I need between 1 and 31.
Hmm.
Of course, this may lead to some impossible birthdays like 31st of
Yeah.
April,
Yeah.
unfortunately. But then you ignored that list.
Yeah. Yeah.
Like suppose now I have 2 and as the day and date and 5 as the month, so this is 2nd of May.
One of me. Yeah.
Now I'll need to make this, so I'll say this number into 100 plus a simple arithmetic operation to convert that 5 and 2 to 502.
Okay. Okay.
So when I press enter, like of course the number will change because every time you tap on the sheet, the RAND command gets activated. There are
Truly
new,
random. Huh.
yes. So new,
Yeah.
so now see 1 and 28 has become 128.
Hmm.
So this is basically 128 is 28th of January. Okay.
Hmm.
So now if I just double click, and since I had a sequence of serial numbers, now I have 60 birthdays.
Hmm. Hmm.
So
Wow.
this so column D represents 60 birthdays. Now how do I check for a match? So I quickly copy
Sort.
this,
Hmm.
and I first copy it into a separate column, and I copy the values,
Hmm.
and then I sort it.
Hmm.
Okay, so let's say I sort it in the ascending order, and then it is one could scroll down and possibly, hopefully, there is a match, and you can search. Now, do we see
Okay.
that 618?
Okay. Okay.
And if you don't want to do that, then there's another way where you select the entire column and you go to this option of conditional formatting.
Huh.
And then you can say highlight cell rules and duplicate values. So you can ask it
Oh.
to mark duplicate values,
Huh.
and you scroll down. Now it says 602. There are more than two matches actually in this particular set. 602 would be 2nd of June, and 618 would be 18th of June. Anyway, the date, the
Huh.
birth day per se doesn't matter, but the fact that there is a match, at least one should be there. And in
Okay.
this list, there happen to be much more than one. There are three. So I keep doing this. So I keep
Huh.
on tapping on this sheet. Each time I tap, I get a new set, and I can copy it to another column and sort it. If you do it 10 or 12 times, you will see every time there is a match. So students tend to get convinced that yes, when I have 60 birthdays, it will. But
So
I
I
feel,
have a question here.
yes,
You've said a very crucial thing. Students tend to get convinced, but
yes,
we need to get them to justify.
absolutely.
So how do you do that? I think you've explained that too in the article, right?
Yes, yes, absolutely. Because I
Yeah.
don't think that we can just talk about the use of technology without the mathematical basis, it would be quite meaningless.
Hmm. Hmm.
So, this is just to show that you can simulate it on Excel. You can't physically keep talking to people and asking for birthdays, it's not possible. But after a few actual checking, you can actually do it on Excel. But
And you
how
can
to,
make a conjecture, right? So,
absolutely, yes.
yeah, yeah,
You can make a conjecture that will always be true.
yeah.
But only when you prove it mathematically, you will see that it is true. So for that, you need to do a little work. You need to use the idea of probability to uh, write an expression which models the probability of a match in a group size of n people.
Hmm.
This is a generalized formula. You can build it up from group size of three. Now, when there's a group size of three people, only three people, the probability of a match is very small,
Yeah,
0.0082. It keeps
yeah.
on increasing. And finally, if you like in this case, I use this Mathematica code, which allows you to plot the probability. So on the x-axis, if we mark the group sizes, and on the
Yeah.
y-axis you mark the probability, you can see that very soon, by the time you get to about 60 people,
Huh.
uh, I think I need to hide this. Sorry, apologize for that. Yeah. So you can see on the x-axis 10 to about 70. So by the time you come to 60 people, the probability of a match is very close to 1. It
One.
approaches, and that
Yeah,
is why it happens.
yeah,
So this is the mathematical reasoning for the birthday
yeah.
paradox.
I think the details are all in the article. So let's move on.
Right,
And we will post the link to the article so that readers can follow up. Hmm.
right.
Yeah,
Yeah.
yeah. Okay.
So,
So would you like to move on to the spaghetti problem now?
yes,
Or is it, yeah? Yeah, okay,
yes.
great.
So, as I said, At Right Angles has come out with several types of these articles where spreadsheet has been used as a primary vehicle for exploration, mainly simulation. Uh, and but this has to be supported with the mathematical reasoning and the proof and the argument and so on and so forth. Now, another very interesting problem which is accessible to students typically from, let's say, grade 9 upwards, is the spaghetti problem. It could be anything. It could, instead of spaghetti, it could be noodle, it could be anything actually, vermicelli for that matter, sticks.
Yeah. Anything that breaks, a stick that
Anything
breaks.
that can be broken,
Yeah.
yes.
Yeah.
So we are saying, let us assume that there is a stick, a
Hmm.
spaghetti stick of length L, and
Hmm.
we break it into three parts. So what is
Hmm.
the probability that the three pieces will form a triangle? So there are three smaller line segments now. So suppose this is the spaghetti stick, and we break it into three parts. And
Okay.
maybe, so when you ask people, children, students especially, that will the three pieces, what is the chance that these three pieces will form a triangle? Now you're randomly breaking the stick, right? You're not fixing any particular place. So in this case, they happen to form a triangle. So people say it's largely 50-50. Like probability of a triangle being formed is around, should be half,
Hmm.
50% is the chance.
Hmm. Hmm. Hmm.
But then is it so? So we need to get deeper and analyze it a little more. Of
Hmm.
course, by the time they come to grade 8 and 9, they know the triangle inequality. That
Hmm.
if you have three line segments, then they'll form a triangle only when the sum of, uh, like the sum of two should be greater than the third.
Third one. Otherwise, I'm sure they would say 100% it will form a triangle.
Yes, yes, true, true.
Yeah.
So we can now do a graphical analysis. First, we'll do a mathematical analysis of the problem. Like suppose this
Yeah.
is the stick, and these two black lines indicate whether there will be a break.
Hmm.
So if we break the stick at these points, then we have, let's say the lengths of the pieces are x and y, and the third piece is dependent on these two, so L minus x minus y.
Hmm.
Now using the triangle inequality, now there are these three pieces, so they will form a triangle only when either one of these cases happen. These
Hmm.
three cases, either x plus y is greater than the third piece,
Hmm.
or x plus this piece is greater than y,
Hmm.
or y plus this piece is greater than x. So that's one thing. And
Okay.
the second thing is that every time you break a stick, so now I may be writing a bit. So every time you break a stick, you generate an x and a y value,
Hmm.
and you get an ordered pair x comma y.
Yeah.
I hope my writing is visible.
Yes, it is.
So now every broken spaghetti stick is being modeled by an ordered pair x comma y, which we can plot on the x and y axis. In fact, they would be in the first quadrant because x and y should be positive, otherwise
Hmm.
there would be no length, and they would therefore be in the first quadrant. So whenever you get a stick, if you measure x and you measure y, and you get the ordered pair x comma y, it would lie in the first quadrant. But now if you look at these inequalities, let's say x plus y is greater than, strictly greater than L minus x minus y. If you simplify this, you get x, x plus y is
Greater than L by 2, right?
greater than L by 2. Yes. And in this case, x and minus x cancel, and here you get x, sorry, y should be less than L by 2.
Hmm.
And in the third case, uh, y and minus y cancel, and there is this. So you get x less than L by 2.
Okay.
Now, also we must keep note of the fact that your x plus y cannot exceed L. Sorry,
Hmm.
x plus y cannot exceed L,
Hmm.
because
Of
the
course.
entire
Hmm.
piece length is L. So even if they're
Hmm.
just two parts, they have to add up to L at least.
Yeah. So they have to be
So
between L by 2 and L.
yes, so x plus y, they have to lie between x plus y greater than L by 2, and but they should be less than L.
L.
So if you draw these two lines, they happen to be parallel.
Hmm.
And also we have the line, we need the line y is equal to L by 2 and x equal to L by 2. And when we do plot these inequations together in the first quadrant, the
Hmm.
common value will come out to be, the common feasible region, so to say, will come out to be this triangle in the center, which is DEC. Now see,
Hmm.
every time I said that every time you break a stick, you have an x comma y, which
Hmm.
gets plotted. Let's say
Hmm.
we keep breaking sticks, so we will get these points inside, but they will lie inside this triangle OAB. So
Hmm.
entire sample space. So suppose I break 1,000 sticks, the 1,000 points will all lie inside the triangle OAB.
Hmm.
But only those which lie in DEC, we can check it because x plus y has to be greater than L by 2, so it should be on this direction. y less than L by 2 and x less than L by 2. So it all converges here. Only those ordered pairs or spaghetti sticks which lead to ordered pairs lying in this triangle uh, will actually form, those three pieces will actually form a triangle.
Oh, okay.
But the entire OAB gives all possible cases. So therefore, but we see that that triangle OAB is divided into four equal parts and DEC is only one fourth. So imagine that we break lots and lots and lots of spaghetti sticks, and this triangle OAB gets densely filled with these points. Then we can say that it approaches the theoretical probability, that the probability of getting sticks where the three pieces actually form a triangle is one fourth of the is one fourth. I mean, the theoretical probability is one fourth.
One fourth. So not half as this conjecture was.
Yes, not half as people tend to believe. So this is an analysis, a mathematical analysis of the problem, and this can be done by grade 11 students because they study linear inequations and they have already done triangle inequality before this, so they can put the two together, and we can stop right here because if you don't have access to technology, we have done enough to prove that the theoretical probability would come out to be 1 upon 4. But if we do have access to a spreadsheet now, we can actually uh, simulate it. So I would just like to share that a little bit here because this was also there in the article.
Hmm.
So let us see how we will simulate it on Excel. Their simple commands have to be used. Let's say that the length of the stick is L units,
Hmm.
which is 100. Let's say 100 units, and there are two breaks X and Y, and this
Hmm.
leads to three pieces of lengths A, B, and C respectively. Now, if you observe carefully, the lengths of A, B, and C are very important because if any of these lengths, A, B, or C, is equal to 50, 50 is half the length of the stick.
Hmm.
So, if any of these lengths is 50 or more, then those three pieces will not form a triangle.
Hmm.
This is a corollary from the triangle inequality itself.
Hmm.
Obviously, like if you have a stick of length L and you have two half pieces,
Hmm.
and one of the half is broken into two other pieces,
Hmm.
those three will never form a triangle because it will all straighten out and there will be no
Hmm.
angles found.
Hmm.
So one of the pieces, the biggest, the highest, the largest of these pieces has to be less than 50 for a
Okay.
triangle to be formed.
Yeah.
So after I've simulated many such ABC lengths, I need to check how many of them satisfy the condition that the largest value of A, B, and C, the maximum value of A, B, and C, should be less than 50. So to do this, basically we again use the rand between command between 1 and 100. So what we do is we generate an x value and a y value, indicating the points where the stick is broken. The smaller of the x and y is assigned to A,
Hmm.
and the difference of y and x is assigned to B.
B.
And the total length is 100. 100 minus A plus B is assigned to C. So these are put in the using conditional statements and
Okay.
also a simple arithmetic statement here. So steps to up to four are just you know simulating the lengths ABC. The next step is to check whether this ABC forms a triangle or not. So as we said, maximum value among these should be less than 50. So
Hmm.
we use that maximum command within the conditional statement and we check if the maximum value of these three is less than 50, then the output should be yes
Yes.
or no. And finally, in that column, we need to count the yeses because the yeses are the cases where triangle will be formed, and that upon the total number of cases gives us the empirical probability.
Okay.
So let me just go back to the spreadsheet. Now, this is already done on the sheet. So, as I said that this. So should I do the simulation and show, or should I just explain it from the what would be more uh, well, I guess I could just tell you quickly how it is done. So let
Yes.
us,
If you could do that, it would
okay,
help.
okay, great. So here we have, I say rand between, so we have the same command that you saw earlier,
Hmm.
but 1 comma 100 because the stick length is 100 units. So we get a length for x, and remember x is the first breaking. It could be first or second. Now here
Huh.
see,
Huh.
67 is greater than 34.
Hmm.
So now I will use an if condition. For now I need to assign a value to a. A should be the smaller of these two.
Huh.
So I will say if b2, that is the value of x, is less than c2,
Hmm.
then the output should be b2, else it
Okay.
should be c2,
Okay. Okay.
like that. So this is a conditional statement. Let's see. Now just see what happened. X and Y, X turned out to be 20 and Y turned out to be 24. So smaller value has been assigned to
Hmm.
A. Then another conditional statement will come here. So I'll say if B2 is, so I'm just putting in the statement. So let's just see if this is working. So what we did is down, let's see, as I told you, every time I tap on the sheet, the rand between will give a new number, right?
New
Now
number.
let's say so the first number is 65 and the second number is 19. 19
Hmm.
is smaller, so 19 is assigned to A. The
And
difference of
B is
68,
65 minus 19.
yes, B is 65 minus 19, and
Huh.
C will simply be 100 minus the sum of A and B.
Yeah.
That's one way of doing it. There could be other ways.
Huh.
Now let's see it again. Now I have 54 and 2. So 2 is
Hmm.
assigned to A. Difference
Hmm.
of 54 and 2 is assigned to B. And the
Hmm.
third piece is 46.
Hmm.
Right? Now we
Hmm.
need to check if a triangle is formed or not. So I will say, let's check again in conditional statement
Hmm.
if the maximum value
Hmm.
of these three,
Hmm.
which is
D,
A,
E, and F. Hmm.
A, B, and C, which we just tap on this cell. The beauty of Excel is you don't have to type, you just tap on the relevant cell.
Hmm.
If the maximum value is less than 50, then only a triangle will be formed, then the output should be yes, else the output should be no. That's
Hmm.
the typical format of any
Yeah.
conditional statements. If the condition, then what, and else what? What should be the output?
Yeah.
So this is what we do. Let's see now. Let's see if this is correct. X value is 7, Y value is 32, so A becomes 7.
Hmm.
B becomes 32 minus 7,
Yeah.
which is 25, and C is the difference. But the highest among these is 68, which is beyond 50. Maximum value of ABC is more than 50, so output is no. These three pieces will not form a triangle. So
Oh.
I hope it is clear because as we said that a triangle can only be formed if the maximum value of A, B, or C is less than 50, which is half the length of the stick,
Yeah.
right? So in this case, it is not forming. The
Jonaki,
output
just
is
1 minute.
yes.
I noticed from some of the comments that someone wants an explanation, but I'm not very sure which point they want an explanation for. So
Okay.
I would request viewers, if you have if you'd like Jonaki to repeat any particular point, please just put it in the chat box, and she will do that. All right. If you need any clarification, please type the specific doubt in the comment box. Okay. Thank you.
So at the moment, I am not able to see the comment box, but
No,
should I just?
I will
Okay.
pick it up if
Okay.
it is
Okay.
posted.
Great.
Yeah, yeah.
So I just wanted to say that every line of this spreadsheet, this is a
Yeah.
single line that you see is simulating one stick. So
Huh.
one stick has been broken into X and Y are the breaking points. Then you simulated the three-piece lengths A, B, and C, and you checked whether the largest among these three is more than 50 or less than 50. If it is
Huh.
less than 50, this last column G will say yes, triangle is formed, else no, triangle is not formed. So these are the only possibilities. Now, now I have done for one stick, but within a second, by simply selecting all these cells, because formulae have been put in all these cells,
Hmm.
and by double clicking, I can within a second simulate 100. Now I'm going down and scrolling down to show you that 100 sticks have now been broken.
Okay.
And in some of them, as you can see, some of them it says yes and some of them it says no.
Okay.
So only the yeses I want to count. The
Count
yeses,
out of the
total number
100.
of yeses, yeah. The
Yeah.
total number of yeses upon 100 will give me the no, the empirical,
Yeah.
not the theoretical, the empirical probability, experimental probability of these 100 simulations. So I'm going to write it here. I use a count if command. It's called count if. It's a conditional statement with counting. Now notice that Excel will also tell you what to do inside the command. It is saying
Hmm.
provide the range and the criteria.
Hmm.
So my range is column G. In column G, specifically from cell G2 to cell G100, sorry, it should be 101 because I have gone up to 101. And the criteria should be yes. I want to count all those cases where it's a yes.
Okay.
But that is a total count, and that upon 100 should give me the.
Yeah.
Let's see if this works. Yeah. Oh, it has given us exactly one
Point two.
upon four,
Wow.
but
Wow. That's
that's
a clue,
lucky. We got
right?
lucky. No, but it so now let me tap on the sheet again. So I've come back to
Yeah.
any one of these cells.
Hmm.
The moment I tap, see what has happened. The entire sheet of 100 simulations has been repeated, a
Yeah.
different set of 100 simulations. And now the probability is 0.19.
Okay.
And I keep doing it. I keep
Which
tapping
is
every time.
exactly what happens if you really broke 100 strings, right?
Yes. Now see it is as low as 0.14. So
Huh.
here students might ask that how is it then every time I'm getting a different value?
Yeah.
One way to answer this is okay, keep doing this many times so that and keep gathering the data. Like every
Yeah.
100 simulations, what is the probability?
Yeah.
And then finding the average of that.
Huh. Huh.
Alternatively, because Excel allows you to do such things, you can actually increase
Increase it
this
to
to
1,000
10,000,
strings. Yeah.
1,000 or even 10,000. It's
Huh.
it takes as much time to generate a sheet of 10,000 broken sticks as it takes to 100. So I can just increase this column to 10,000 and just repeat this command because the formulae are already in.
Remembering to change that countif range,
Ab-
right?
Yes, absolutely.
Yeah.
So we need to, then we can just change it to 1,000 or 10,000 and the cell range. Very right.
Yeah.
So this helps us to, this is a different approach from the mathematical analysis. But it is convincing once you've understood the mathematical analysis, you're expecting 1 by 4 to come up. So you are happy even if it's 0.23 or close to 0.25, if not
Hmm.
exactly 0.25.
Hmm. Hmm.
But at least you're getting an evidence that yes, it might be true.
Yeah.
Now, if there are any questions from the audience related to specifically this simulation, I'll be happy to
No,
answer.
I think it was before you actually showed the details, but
Okay.
now there are no questions.
Okay. I hope it is clear to everyone, but
Yeah, I hope
later
so too.
also, yeah. So I repeat that every row of this sheet uh, is basically this is a nice mathematical, what should I say, representation where every row represents a broken stick, and the information given tells us the length, size of those piece lengths, and the last column tells us whether those piece lengths form a triangle or not. So nothing
Oh,
much more than that. But when students are given that this opportunity, so one of course is mathematically analyzing the problem, but when you want to simulate it on Excel,
huh,
you have to figure out what commands to be used for your to serve your purpose. So
huh.
the steps under creating these are visualizing or envisioning these steps of simulation, I think entail computational thinking. I'm just bringing in this term now because mathematical thinking and computational thinking are very much interlinked, and they have a lot of commonalities and differences too.
Hmm.
Sometimes it's hard to segregate and say which part is mathematical thinking and which is computational thinking. But this would be in the realm of computational thinking, where we need to logically break down the problem into smaller bits and be able to search for the right approach or right command on Excel, which will lead to what I need to.
Hmm.
So mathematically, I know that I need three piece lengths A, B, and C, and I need to check whether the maximum value is less than 50 or not. But how to get it to happen? How do I make it happen? So that creating that would need a little bit of computational thinking. So we discussed two approaches of the spaghetti problem. One is the mathematical analysis, which leads to the theoretical probability 1 upon 4, and the simulation on Excel, which leads to the empirical probability. And as you do the simulation more and more, the larger the number of sticks that you break, the closer you would hopefully get to the theoretical probability.
Janaki, I just have one question. You
Yes,
know, naturally, when you write an article, you will have to describe how the investigation was carried out in Excel.
yes.
Now, when a teacher does such an activity,
Hmm.
if she gives them what has to come into every cell, then actually they are not doing much of computational thinking. And
Yes,
if she derives the result for them, then there's not much of mathematical thinking happening either.
right.
So, how can you give some suggestions on how the teacher should actually do this exploration in the classroom? What should she say? How should she facilitate their thinking and their growth without actually giving away the answers?
Yes. Well, maybe I could share with you what my experience was with
Yeah.
a set of grade 11 students. And then I tried it with a grade 9 also later.
Okay.
My first group of students were grade 11, and they were quick at it because so when I first posed the problem, I mean, I did it, ask them to bring these sticks, and they broke them and they tried it out.
Hmm.
And as you could see, some of them got triangles and some did not. Now, not everybody got the sticks, of course, but
Hmm.
those who got them. So now, probably that was a class of about 35 or 36 students, and maybe only 15 or 16 had brought the sticks. So they were
Hmm.
asked to bring, some forgot, and things like that.
Yeah.
Now, when the when 15 broken sticks were arranged, some formed and some did not form. So it did not help them to guess what the probability would be. But they said maybe it is 50-50. We can't say, we're not sure, we can't say, but chances are 50-50. Then somebody argued that how can it be 50-50, and it's not like tossing a coin where it's exactly one two possibilities and one of two possibilities will emerge. So
Hmm.
conversations were coming up. So I think
Hmm.
one important thing for a teacher is to be very alert to what students are thinking and saying, and not be quick to and sometimes they bring up surprises, and you have to also, sometimes you may not even have the answer. So after these students did it with the sticks, then of course then the triangle inequality and that entire analysis that
Hmm.
they could do very easily, they could understand because they had already done the topic of linear inequations and how to get a common feasible region. That part they were
So
okay.
that was actually taught to them.
Yes, that they had
Because,
already done in their regular class, and I was doing this experiment with them separately. So they
huh.
were able to apply that knowledge of linear inequations to model
Hmm.
this problem.
Okay.
But this idea was very interesting. So then we said that okay, when you break a stick, we have two lengths x and y. Can we plot them on the x and y axis? And then immediately somebody said yes. Then we would get these points because we would
Okay.
get ordered pairs because these
Oh,
were grade 11 students. But my
yeah.
experience with grade 9 was also very encouraging because grade 9 also they know how to plot points. So when they see an x and a y, they guess that oh we can plot them on an x
Hmm.
and y axis.
Hmm.
So that was one thing. But so mathematical analysis, a teacher could do two things. One is you discuss the linear inequation, the triangle inequality, and what inequations it leads to, and stop there. And then maybe move on to the Excel simulation, go back. So you can also toggle between the two.
Hmm. Hmm. Hmm.
That's also a good approach.
Yeah.
But here, because the grade 11 students, when I wrote the article, I was basing on their understanding of the problem. So they figured out the one-fourth probability first, and the
Hmm.
first thing is oh wow, they were like oh my god, we thought it was half and now it's one-fourth. Okay,
Huh. Hmm.
and then of course we said okay, let's verify it. So though I did tell them that they had to be initiated to the RAN between command and all, but some of them had a computer science background and they knew what random number generators were and all. In fact, some of them went on to writing programs in other languages for this. But
Okay. Okay.
but the Excel was a simple thing which everybody could do. So even a student who does not know computer programming, Could
Hmm.
easily use these simple commands and simulate the problem. I think that was the good part of it. So
Hmm.
a teacher could do both. But the point is that the problem didn't stop here
Hmm.
with the case of three pieces forming a triangle. What
Okay.
happened after that is that one natural question that came up is, okay, if the same stick is broken into four pieces, so
Hmm.
now it's an extension to the problem. Will the four pieces, can they be arranged to form a quadrilateral?
Hmm.
Now everybody was very, there was conversation between the students. Okay, a quadrilateral can be divided into two triangles if you join a diagonal. So does that give us any insight to answer this question? Then I started probing them. Do you think the probability will be more than one fourth? Because for the three case, n equal to three case. So now they knew, because they were grade 11 students, they had a sense, sixth sense, saying that yes, maybe there's a general version to this problem. But
Hmm.
first they would focus on, I said, you focus on n equal to 4. How will we argue whether these four pieces will form a quadrilateral or not? So some of them said, okay, because we've already done the simulation, we can just at least extend it and see what happens. So here, they did not know the theoretical probability. In the other case, they knew the theoretical probability was 1 upon 4 before, and then they verified it using Excel. Now they were
Yeah.
hoping that Excel would tell them or give them a kind of a clue what the theoretical probability. And here they were not, none of them said ki it will increase or decrease, and they were just not sure.
Hmm.
So then we said, okay, now the same stick has to be broken in three places to get four pieces. So this is a snapshot of an example where you have an X, Y, and now a Z also.
Hmm.
And you have four pieces A, B, C, D. And do they form a quadrilateral? Now, again, the same idea was used that if your piece is of length 100 units and
Yeah.
one of the pieces is 50 or more, and the
Ah.
other three pieces add up to 50, then those four pieces cannot form a quadrilateral by the same logic in
Yeah.
the triangle case.
Hmm.
So, well, in this case, what essentially happened is, I'll just quickly show you the whole case, n equal to 4. Now, here, just see now here, look at the probability. So I am tapping the sheet. Now, by the way, this sheet has 1,000 simulations of spaghetti sticks broken into four pieces.
Hmm.
So here you can see again, does it form a quadrilateral? There are yeses and nos. So we counted the same way, exactly the same way. Now I'm getting 0.497. So the students kept tapping 495. Like, obviously you're getting different values, but sometimes it was increasing, going beyond zero point 0.5.
Hmm.
So then they kind of guessed that it could be around half because
Okay. Okay.
and and some child said, okay, I'll go beyond 1,000 also. I'll stretch it to 5,000 and see. And of course,
Huh.
it's better in that case.
Huh.
So now there was a conjecture that maybe the probability for four pieces forming a
What's
quadrilateral is half. There's a conjecture. Okay, so what to do after this? Now there is a theoretical proof of this, so that had to be discussed by me because otherwise it was not. I mean, I that is honestly that's the only proof I know.
yeah.
And here we have to. It's basically what it's a simple idea. We say that now we have four pieces. Let's call those pieces N1, N2, N2, N3, and N3, N4, and N4, N1. And we all these pieces add up to L. So let's
Hmm.
arrange them. If we can bend the spaghetti stick, or let's say it's a noodle or whatever, or a string even, let's bend it to form a circle of whose circumference is L units.
Hmm.
And how will we prove that the probability is? We need to prove that the four pieces forming a quadrilateral is half. That was what we wanted to prove.
Yeah.
So the logical thinking behind this was that let's take any one of these 4 points
Hmm.
and note that the circle itself represents the spaghetti stick.
Hmm.
So let's take a diameter of the circle through one of these 4 points. I choose N1, let's say. I have four
Yeah.
choices. I choose N1 and I draw the diameter. Now we observe that any one of these points, let's take N2.
Hmm.
N2 will either lie on this semicircle or it will lie on this other semicircle. Every point has to lie on one of the semicircles. So the probability of N2 lying on any one of these two semicircles is half. Half is the probability that it will lie here, or half is the probability it will lie on the other semicircle. Same is true for every point. Now, why is this important? Because if all the points, if N4 was suppose here, in on the same side as N2 and N3, would these four pieces have formed a quadrilateral?
Hmm.
I,
So
I, I repeat my
again, you're going to half the perimeter, I notice. I mean,
yes,
half
half
the
the length, yes.
half the
Because
length of the stick.
exactly,
Hmm.
because if N4 was here, let's say, all the 4 points being on the same semicircle means one of the pieces is greater than half the length. And then
Hmm.
in that case, quadrilateral cannot be formed.
Hmm.
So what is the probability that all the 4 points will lie on the same semicircle? That probability is half into half into half.
Hmm.
Half for this point, half for this point, and half for this point.
Hmm. Hmm.
But I can choose, I could have drawn any diameter, I could have chosen any one of the points. So there were four choices with me initially. So 4 into 1 by 2 cube, that is actually 4 upon 8 and half. So
Hmm.
half is the probability that these four pieces, N1, N2, N2, N3, N3, N4, N4, N1, will not form a quadrilateral. I
Which
repeat,
is,
not form a quadrilateral.
yeah, yeah.
But 1 minus that is the complement of that, will is the probability. So therefore, the theoretical probability is half.
How lovely. Hmm.
So this is simple because students also are familiar with the concept of probability little bit. So it doesn't use very technical knowledge of or of permutations, combinations. It's just simply choices. That's all. I
Hmm.
have four choices. I choose one of them. That is 4C1, and for each point the probability is half. So which like that. So this idea could it could be just general use for generalization. And you can ask now the question that if you have a spaghetti stick of length L and you break it into n parts, what is
Hmm.
the probability that these n pieces will form an n-sided polygon? So right from quadrilateral you can jump to, you need not do pentagon. And other students started saying, now we know, I mean, why should we look at pentagon case, n equal to 5 or n equal to 6? We just want the general case now. I said, can you argue the same circle idea? Can it be stretched to the general case? So there
Hmm.
was some arguments and some thinking, but ultimately we figured it out.
Hmm.
So this was the case that
NC1.
uh,
Yeah.
so now the endpoints are now placed. Now probability of each point being on one of the semicircles is half. So
Hmm.
if you choose n1, there are n minus 1 points left. So probability will be 1 half into half into half n minus 1 times, and therefore it is 1 upon 2 raised to the n minus 1. And in the numerator it is nc1 because you have n choices. So this is
Hmm.
the probability that the pieces will not form an n-sided polygon. And therefore 1 minus this is the final probability that n pieces will form an n-sided polygon.
Janaki, I
Yes.
there's a request that you repeat that probability part again.
Which one for 4 case n equal to 4 or this one?
I think if
I
you just
can't do
say,
that.
yeah, if you say n equal to 4, I
Huh.
think the general case will become very clear.
Or okay, I can do that. Sure.
Yeah,
Uh,
yeah.
Let me go to the diagram. Okay. So let's see. This is the semicircle. This is the circle, and I have point N2, N3, and N4. So what is the probability that N2 lies on this semicircle? Let's fix the semicircle.
Hmm.
What is the probability that N2 lies on this semicircle? It is half. It has to
Ah,
either lie here or here, one of the
yeah,
two, because it has to lie on the circumference of the circle. So it has
yeah,
to be either here or here. So probability is half. For this is for N2.
yeah.
Similarly, let's take N3, the probability is half. So the probability that both lie on the same circle is half into half by the principle of multiplication. And if we take N4, what is the probability that it lies here? Same semicircle, let's say somewhere here.
Hmm.
That will also be half.
Yeah.
And N1 is here. So they all lie on the same semicircle, and the probability of that happening is half into half into half, which is 1 upon 8. But I, I divided the circle with this diameter by choosing one of the 4 points, which is N1. I could do the same thing by choosing a diameter through N2 or through N3 or through N4. So I have four choices in the beginning to start with.
Yeah.
And any of those four choices would lead me to a probability of 1 upon 8 for the other 3 points. So to model that, I say 4C1 or simply 4. 4C1 is 4.
4.
So 4 into 1 by 8 is actually
Half.
comes out to be half.
So that's the probability that they do not form a
Do not
quadrant.
form, because see, if your N4 is here, then the N1 N4 is greater than half the length.
Yeah.
The fourth piece is greater than half the length of the stick, and so
Huh.
in such a case, a quadrilateral will not be formed. So in
Okay.
probability, we know that if we have a probability of an event not of an event A not occurring, then the
Yeah.
probability of that occurring, the complement, is 1 minus the probability of that. So therefore, 1 minus half is the theoretical probability.
Yeah. Yeah. I think it's clear now. The person is posted that it's clear now. Mhm.
And so here, same thing. Now see, if you put n equal to 4 here,
Huh.
because this is a general formula, so let's just quickly put n equal to 4 and check if our conjecture of half is correct. So probability of four pieces forming a quadrilateral should be 1 minus 4C1 upon 2 raised to the power 4 minus 1, 2 cube. And that's exactly what we got.
So I want to try it for that triangle inequality.
So put n
N
equal
equal
to
to
3.
3.
So
Yeah.
1 minus 3C1,
Hmm.
which is 3, upon 2 raised to the power 3 minus 1, which is
Wow.
2 square. So it is 1 minus 3 upon 4,
Which is 1 by 4, which you
1
got.
by 4. Yeah. And in fact, as I was,
1
we
by
were
4,
amused.
Jonaki. 1 by 4, the
Oh, so
last.
sorry. Yeah, I apologize. Yeah, 1 by 4. So we verified using the general formula, we can verify special cases. Now this problem also leads us to generalization and specific cases.
Huh.
That the triangle case of three pieces is a special case of this problem,
Yeah. Yeah.
the
Yeah.
generalized problem. And so this part, of course, needed a little bit of work, but when it was discussed using the quadrilateral case, this became a sort of a very quick way of
Mhm.
generalizing. But this is because they were grade 11 students. But with the grade 9 students, we were just able to discuss the quadrilateral case.
Hmm.
And I felt that it would be too much to go into
Yeah.
this.
Yeah. Because
So,
combinations and
yes,
even probability is done more at grade 11.
yes. In fact, we did not use for class 9, we did not use the term 4C1. We simply
Huh.
said there are four choices to begin with
Huh.
for making the diameters, and therefore it's 4 into, for each, of course, they use the idea of probability.
Yeah.
So this is how it went. And
Hmm.
another interesting thing is, if you actually see that if you keep on increasing the number of pieces,
Huh.
the probability of forming an n-sided polygon goes on
Huh.
increasing.
Hmm.
And so if you break one single stick into 15 pieces, in fact, it reaches 0.99 very quickly by 12 pieces if you round it off. You see that as you keep on increasing the number of pieces, you can be certain that those pieces will form an n-sided polygon. So if you
Yeah.
have 15 pieces, you can be sure that those 15 pieces joined together can form a 15-sided polygon.
So this bit is not in the article, I think,
No, this
correct?
bit was a
Yeah.
kind of,
So you can actually, people can just keep building on the stuff.
yes.
Here's a question from Akash Maurya saying, why do we call it the spaghetti problem?
Well, you can call it whatever. You can call it a toothpick problem if you can break it, or the stick problem. I mean, doesn't the
Yeah.
name doesn't matter. The idea
Yeah.
is that you need a line and you need to something
A,
which is straight.
a kind of brittle line
Yes.
which can be broken, and spaghetti being a brittle,
Yeah.
uh, dry uh, food material is easy to use, common, and
Yes.
yeah.
Popularly, it is known as the spaghetti problem, but you can call it a vermicelli problem or whatever,
Yeah,
a
yeah,
noodle problem.
yeah,
But
yeah.
yeah.
Uh-huh.
So I think with this, I just like to sort of share that. These kind of problems, now why do we, now we could call this problem an exploration, and it would be good if we could integrate such things in the curriculum
I
for
think you
grading.
proved your case, Janaki, because there's
Yeah.
just been so much the student can grow
Yes,
through doing this. And I think the most heartening thing is things which you're using, starting from area of a triangle
yes,
to graphing a
absolutely.
line, linear inequalities, probability, combinations, all of that has come together so beautifully in this,
Yes.
simple exercise of breaking a stick and thinking.
Yes, so much can is encapsulated in this one thing, and
Yeah.
it this strength. I mean, if I when I did the problem, I was not worried which part is mathematical thinking and which part is computational thinking. I just
Hmm.
thought that the two were so intertwined with each other. But at certain points, I could see some students could catch on very quickly. Oh, if I use this command, then I will
Hmm.
get what I need to do. Whereas
Hmm.
some were saying, okay, let's see you do it. So that is also a very healthy situation to happen in the class, because some people may be good with you know simulating it, and others may be good mathematically, and they complement each other. And I
Yeah.
think that is so important. It is not important to give them statements and say, okay, now you go and try it out. So
Hmm.
these problems need to stretch over a few classes. It can't be done in just one period of 45 minutes. You have to spend at least 2 3, or you give them the problem. The other issue is that if you give them a problem, and they just go and look up the internet and find the solution, I'm sure the solution is available somewhere
Yeah.
now in the days of chat gpt. I mean,
Yeah.
so so you have to ensure that you pose the problem, give them time to think and get their initial ideas, so that even in one class, if your work doesn't get done, if the entire problem is not discussed or solved, you have the fresh ideas from the students, not what they have studied on the internet. Maybe they'll go back and look up the internet, and if they've understood from the internet and they are able to come and present the solution, I see nothing wrong with that either. So what I'm trying to say is that in this day and age of technology, we have to be prepared for a multi-pronged approach in the classroom. And
Yeah.
I think I'll kind of stop
Thank
here
you
and
so
if there are
much,
more
Jonaki.
questions.
And you've really illustrated your point so well. I have one question from Varish Theda. Ma'am, if you can kindly elucidate how computational thinking in students can be developed independently without using any technological tool. So basically unplugged
Unplugged
activity.
activities, yes. I think, should I stop sharing before I answer, or
I think you have.
I've stopped sharing? Okay,
Yeah, yeah, yeah. I
okay,
think the screen has been removed.
okay, okay.
Yeah.
So, I think unplugged activities, one needs to identify these games and puzzles which don't need the use of computers, and they should be integrated much earlier in the early school years, not
Hmm.
wait for middle school or secondary school. And there's so many such problems. We can find them in many puzzle books and things which every child. I think it is important to identify problems which every child can at least attempt. So,
Hmm.
Sneha, as you know that you have also worked very closely with low threshold
Yes.
and high ceiling tasks,
Hmm.
where
Hmm.
there are tasks where every child is able to do something, and there's some children who might take the task beyond a certain level. And there are so many problems. Like there's this very interesting simple problem, but which is not so simple when you really analyze it deeply mathematically. Like suppose we say there are these 9 coins, identical looking 9 coins, but one of them is faulty and is heavier than the rest,
Hmm.
but they all look identical. So you have to, and you are given a weighing balance. You have to balance them out. No weights are given, but you can weigh the coins against each other. You just have a weighing scale, a balance scale.
Hmm.
Using that balance scale and these 9 identical looking coins, you have what is the minimum number of weighings required to identify the faulty coin. So
Hmm.
children will start saying, let's pick two, let's weigh them against each other. If they are same, keep them aside, they are fine. So that's how it starts. But the
Yeah.
real realization that what is the optimum grouping that needs to be done and weighed against each other to figure out with the least number of weights. Here, you need to make a you ask the children to represent the solution, their thinking process using a diagram or by writing. So
Hmm.
you are encouraging them to think computationally. The moment you say make a flow diagram or represent your thoughts using some kind of a diagram, I think it entails computational thinking. So this problem does not require any formula or any mathematical knowledge per se, and anybody can attempt such a problem. But when you
Yeah.
analyze it deeply, it's a not a very trivial problem, and there are many levels and variations
Yeah.
of this problem.
Yeah. Yeah. Um, Also, I just wanted to ask you, Junaki, can you suggest any resources for people who they? I think the CS Pathshala
Yes, website. Yes, yes,
website, yeah. So I think if you look up CS Pathshala, you'll be able to find many such activities. Also,
yes,
I think there's Tim Bell has done
yes.
constructing CT without computers.
Right. Professor Tim
Yeah,
Bell. Yes.
yeah, Tim
University
Bell and
Canterbury.
Michael Lodi. Yeah,
Yeah.
yeah.
If you go
So,
to the CS Pathshala website, you will find lot of tasks given grade wise also,
yeah,
uh, and they are focusing more on the primary and middle school. So that
yeah,
would be a great repository for such tasks.
yeah,
And also that has we have been doing the CTIS conference, that is computational thinking in schools.
yeah.
But there it is not restricted to mathematics. It could be computational thinking in any subject domain.
I've seen that. Yeah, yeah.
Yeah. So
Okay, so we are out of our time. We're past
yeah,
our time, I think. So
right.
thank you so much, Janaki. It was great having you on the show, and
Thank you very
I
much.
hope that we hear from our viewers about how they have incorporated this in their classrooms.
Thank you very much. It was a pleasure to be a part of this webinar. Thanks.